Well, I will share my screen and we might have some other interruptions from
No
kids,
worries.
but I'm not worried. Okay. So I'll tell you a little bit about myself and I'll give you a really brief overview on a wide variety of projects that I've worked on. And then you can just ask me about any of them and we'll just have a conversation. So this is just an intro. Can you see my screen?
Yes, I can see it.
Okay. So first, just about me, my name's Alyson Freeman, and my degrees are in chemical and materials engineering. I have a bachelor's, a master's, and a PhD. And when I was younger, I wanted to be an astronaut. I think a lot of my science interests came around along those lines, everything having to do with space. When I was really younger, I thought I might also be a teacher or a dancer, which came a little bit true in high school. I was a dance teacher and through college and grad school because that was a good way to pay for things. So I liked dance. I liked watching football with my family, going shopping. Babysitting was big when I was in high school. That was my only way of making money pretty much. I like to get my nails done, still do. So I just kind of put this here because when you get into the science world, you'll find all kinds of people that like science and other stuff. It's definitely not a nerdy, quiet guy with glasses that sits in the corner. That's not who I work with. Like, they're all real people, not caricatures, and they all like the same things that you and I like. So these are some of the things that I've worked on in the past. It all started with a science project, science fair. And I was in IB in high school, just like you all. And my chemistry teacher had an idea for a project for me that also helped me get my CAS hours. You guys still do that? The community action service?
I think we do.
Creativity? Okay. You had to earn 100 hours of volunteering. So I volunteered and other stuff, but volunteering was one of them. I volunteered at our county environmental health office, and that also gave me a science fair project that I used for my extended essay. So it was like 3 things for this one project. I highly recommend combining when you can. And the project was testing water sites around the county for which one would be the best thing to augment or add to water already going to sprinklers. Because a long time ago, they would use like the treated drinking water for the sprinklers too. Just water came to your house and that's what it was. And really, we could be much more efficient with our water usage if we save the drinking water just for drinking and maybe use something else that was also clean for the sprinklers, but not quite as pure. So I got to test different lakes and things around our county and tested them for 5 things, like the pH, the turbidity, that's kind of like how clear it is, TSS and TDS, which is total dissolved solids and total suspended solids, really just kind of fun little experiments for the health of the water. And then I recommended which water source would be best for the sprinkler water. And it actually happened, years later after I had helped on a project. And that was really exciting. And the other thing that happened through that science fair was getting an internship at NASA. And if you remember from the last slide, I wanted to be an astronaut. So this was amazing. This is like the best thing that could have ever happened in my life. And this was the summer after high school, before I started college. So I worked on some projects, but honestly, I don't even remember the details too much. I just assisted the senior chemist that I worked under, and I went on some really awesome tours. That's what I remember of that internship. And it was really cool. And throughout college, I also did 2 stints abroad. So one at École Polytechnique Féminine, which is in Paris, and that was a really cool program for female engineers. And what I really liked about that was there was 100 college age girls who majored in engineering there, but only 6 were from the US. And that was kind of the most from any country. And the rest were from all around. So I got a really good view of just how different engineering looks around the world. The classes they take are slightly different, the number of years it takes that they go through school, when they start. And that was really interesting to learn about. And then I also spent a summer in Delft in the Netherlands at the Particle Engineering Research Center. And there I worked on it was particle engineering center. So all the research was around particles, little tiny things that you can't see. And my project was making high aspect ratio particles. So high aspect ratio means large surface area compared to volume. So not a sphere, but something very flat, like a platelet. And the reason they wanted to do it was a project sponsored by the Army. They were looking for something that they could add to a smoke bomb in order to help protect our soldiers. Because if you have a smoke bomb, we have infrared technology that can see through that now. So it's not as good of a diversion as you would want. So the thinking was, if we could put these little platelets that would reflect the beam back to them or mess up their signal, it would be better for protecting our soldiers. So really cool application, awesome. Turns out it's a horrible thing to breathe in for our soldiers, so it's not something that actually went out into happening. And so I think that's something that's really important to know about engineering projects. You know, some of them, like the sprinkler thing, that might work out and it might get implemented. And another thing, you might a lot more often learn what doesn't work and why. And that helps you get closer to a solution anyway. An interesting side fact about that is those particles, those little tiny particles, they were made of precious metals like gold and silver, and they ended up putting them in nail polish. So you could sell like real gold nail polish with real gold in them. So there's alternate uses sometimes. You never know what you're going to end up with. Okay, so then from there, if you're following the pictures along the page, then I worked at Los Alamos National Laboratory during grad school. And that's the place where the Manhattan Project was, where the nuclear bomb was developed. And it was a pretty cool place to work. Not a pretty cool place to live. It is out in the middle of nowhere. You have to drive 2 hours round trip to get to a Target or a Walgreens. Not a great place to spend your early 20s, but I got to do some awesome science. And there I worked on radiation detection. And what they wanted to do was put what's called a scintillator. That's a thing that detects radiation, and it tells you what type of radiation you have. They wanted to put it at borders and toll crossings, because lots of things give off radiation, like bananas. They have a lot of potassium. So it would be fine if a truck full of bananas came into the United States. But what about a truck full of uranium or plutonium that we would want to know about? So the purpose of the scintillator is to read how much radiation there is and what elements are giving off that signal. And the way that they do that, they have scintillators now, but they're really big and bulky and they're hard to use. They have photomultiplier tubes in them, which is those things that are in a old TV, like the ones when they were really thick before flat screens. If you guys know about those, I'm old enough, but so they didn't work. They're too expensive and they're too big and they're sensitive to magnetics. So you don't want that at your toll plaza. So they thought, well, maybe we could do it on a chip. And we could make a scintillator that way. And so that's when I started learning in a laboratory how to make a computer chip. And that's where the rest of my career went. It wasn't always based off of radiation detection, which, by the way, that's another project that does not work. That doesn't exist today. It couldn't give us the right efficiency that we needed. So they tried a bunch of other ways too. But a lot of science is figuring out what doesn't work. So I took what I learned at Los Alamos, and from there, I spent 10 years working at Intel and Samsung, making the chips that go inside at Intel, your computers, or at Samsung, your tablets and phones. And what's interesting is even though Samsung make the chips, it's not just for Samsung phones. It's for pretty much all phone and tablet suppliers. It's funny how they can be rivals for the end product, but all the companies depend on each other for the parts. I thought that was interesting when I started working in that field. And that was working in a bunny suit. If you see the little picture there where you're covered head to toe in a fab facility, that's not to protect me, by the way. That's to protect the wafers. And a wafer is that circle disc thing that you see there that gets broken up. It's got little squares on it, and you pop one off, and that's a chip. They're made in circles. And so at Intel and Samsung, I was a process engineer, and then I started leading projects, engineering projects, and then I started managing people. And then I took those skills of managing technical people from the engineering that I already knew to Dell, where I work now. And now I lead data analytics teams. And now my job is a lot more about explaining where the problems are, how we can use the stuff that the real data scientists are doing, and why it's important, where we are, where we need more funding. It's less hands-on than I used to be, but sometimes careers go that way. So that's kind of the basics. I like the comment. Sounds yummy, wafers and chips. Someone's hungry for dinner too. That's the basics. I have some pictures for each of these that I could flip through, but really I want to know what you want to know about any of these projects or any questions you have.
Yeah, that sounds awesome. You've definitely been around. You've had a bunch of great experiences that we could spend a long, long time talking about. So yeah, that's what I wanted out of this as well. Students, I wanted you guys to be asking Dr. Freeman whatever questions came to mind. So Ayush, Jasmine, what do y'all think?
I'll let them keep thinking. I'll flip through a couple of the pictures because I think sometimes seeing people doing the science as you go along, I don't know, it helps you picture you be in it too. And then I can tell you a little bit more about the data science projects that I'm working on at Dell, especially if there's people particularly interested in computer science. So each of these squares, I haven't looked at this presentation in a while. I think I have pictures from each of these squares. So it's embarrassing, but I've got like high school pictures in here. So this was the science fair project that I was telling you about with the sprinklers, and the NASA internship, which the tours were the highlight for sure. We got to go out to the launch pad and see some launches, and that was really fun. And then this is the place in Paris, got to live in the dorms, experience a different culture. It was the first time I'd ever left the country. So you can think about just how many doors engineering and science can open up for you that you never thought of. This is the Particle Engineering Research Center in the Netherlands. It's not that long ago, but look at that computer screen. Like that's the photomultiplier tube that I was telling you about. They don't always have the best funding for that stuff. So the monitors can be old. And this is what my desk looked like at Los Alamos. And this is what the lab looked like this is where I was working on the scintillators for radiation detection. And let's see. Oh, I didn't know these were in here. So my husband also works at Samsung, and this is my son when he was 3. We gowned him up to come into the factory at Family Day. Oh, this is him now. This is him at 8. He turned 8 last week. Yeah, or 2 weeks ago. Time flies. I was just showing a picture of you, bud. I heard that. Oh, you heard it? And you're in this whole presentation, Spencer. This is him coming to Dell, where I would teach coding for kids classes. Oh yeah, I remember that time. I remember both times. Yeah. So it's been a lot of fun. And I will tell you about some of my Dell projects. And Jasmine's dad works there because we're in Round Rock. Lots of people work there. And there's a good question. Oh, not Dell. Where? Samsung. Oh, okay. On. You have to tell me what you think about it.
They have a facility in Austin, right? Like down by the river.
Yes. Yeah, out by the toll road, actually. Like Farmer and 130.
Oh yeah,
yes, huge factory. That's what those pictures were of. It's the size of 9 football fields. It's very huge. Yes. Big.
Dell's campus is really big too, right?
Yes, but it's all office. It's almost all office buildings.
Okay.
And Samsung's an actual factory.
Gotcha.
Which is kind of cool too.
Yeah.
There are some cool places within Dell where they build servers, and there's a place where they test laptops, the rugged laptops, to make sure they're rugged. So they drop them, they dump them in a fish tank. Like there's some really cool experiments that they do there. And one day soon, when we can all be in person again, we'll have Westwood out for a site visit.
Yes.
At Dell. Yeah.
That'd be so fun.
And maybe even at Samsung too, because I used to do Westwood tours at Samsung, so I bet I could find someone to do that. It's great. Okay, so there's a question in the chat. What were some of the courses you took in high school that related to your current job? Pretty much the maths for the most part. I did use chemistry a lot in my engineering jobs, but now I'm a manager and I definitely don't use chemistry, and I barely use my math, but I needed all those basics from high school. And this wasn't the question, is what are some of the courses you took in high school? There's actually a course in college that I took that has helped me more than any other class I've ever taken, and it's called technical writing. It's how to write to your audience, how to be clear and concise. And that helps me every day now. And it's helped me every day over the last 10 plus years that I've been working. The science is important. Lots of people will figure out the science and the math, and they'll help you. What can really set you apart and propel your career is being good at the soft skills. And I know that Westwood academies are very good at that, about your resume, about your interviewing, about presenting skills. Those are so critical. Maybe even more than the math and science.
Yeah, that's crazy. I've been interviewing several industry professionals over the past year or so, and that seems to be where we always come back to, is the soft skills are what's more important than these technical skills. So that's crazy. I mean, I guess they're both important. You can't get by on the soft skills alone, but those are the things that are gonna really set you apart, and the things that you're gonna use all the time, right?
Absolutely. And it's because every job is so specific and different that you're going to learn the science and math part on the job. And they're not going to expect you to already know it. They're going to expect you to have that way of thinking. And the way you get that way of thinking is by taking science and math classes. But no one's going to expect you to already know something specific about some job at some company. That's just not how it works. So maybe that's why they all say that. And I have to say, you all are really lucky that you're at a high school that teaches these things. It's a huge advantage. There's another question in the chat. Have you ever published a research paper? Yes, I have 5 under my name. I pretty much only did those at the national lab and during grad school. And then once I picked industry for my career, as opposed to academia, which means working at a college or working at a national lab, they don't have you publish papers as much anymore because they're all about keeping whatever you learn within the company. So people who go down a path, people with PhDs specifically, if they work in academia, they're going to publish a lot. And if they work in industry, they're probably not going to publish as much. But it is pretty cool. Patents can happen at academia, industry, and national labs. So patents do happen in industry. I do not have one. I am working on an initiative at Dell. I lead Women in Technology for North America there, and we're working on an initiative to try and get more women into patents. So teaching them the process, helping them assign a mentor, doing patent mining sessions to help come up with ideas and vet whether they're unique enough to be patentable or not. And so I'm in that space in a helper type way, but it would be so cool if I was a science person doing it.
I think some of our seniors who just finished up their projects this past week, I think some of them might be eyeballing looking at the patent route.
We should talk at the next STEM board meeting about how we can set up mentoring through like I am mentoring the people that have patents, the people that want patents at Dell. There's no reason we can't just extend it one step further to young patent enthusiasts.
Yeah, I think that sounds great. Is that a paid program with a fee?
Or no, it's all volunteer.
Oh, awesome. Yeah, that sounds neat. Very helpful.
Yeah, everything we do for women in tech, and I assume pretty much everything you do for Westwood STEM, it's all volunteer.
Thanks for volunteering so much. You've been helping out a whole lot with Westwood.
Oh, no problem. It's a passion of mine. It's one of the best parts. And it reminds me of these times when I did more real science instead of managing people, although there's something really great about managing people and helping them get to where they want to be. It's almost even better than doing it yourself because you get to see it in that. Well, I mean, you're a teacher, so you obviously know, but I'm telling the other people.
Which one do you like more, managing people or doing the hands-on work?
Right now, managing people. I really do love it. I'm glad I got to experience both. It's really important and lucky, I think, if you're a technical person, to have a manager that also is technical, because it's important to know when you're asking someone to do something, if it's a small ask or a really big ask, or, you know, maybe I can't do everything I used to do before, but I've seen a lot of different projects now, and so I can make a recommendation about what strategy to try or who to connect them with. So I think it helps when you have a technical people manager, which is another skill very high in demand. You can go very far in your career if that's something you want to do. That's always in demand.
Yeah, that's a pretty good transition to the question that I had, which was about data science. In my freshman computer science course, we went over data for a whole unit, spent a few weeks gathering some data from Kaggle and doing some analysis on it and some visualization of it. I think they really enjoyed those projects as a whole. So tell us more about the data science that you do currently. What does that look like, and what kind of projects are you into there?
Okay, I have two teams under me. So it's the data analysts, data engineers, data scientists that support two parts of Dell. One is demand acceleration. And so what that is if Dell sends out a laptop to the tech department at Westwood and says, try this out. And let me know what works with your software, everything that you need. And if you like it, maybe they'll buy 2,000 laptops for all of their schools. So it's like a trial unit of a laptop or a server that in hopes that they'll purchase more. So we're trying to generate more revenue for Dell. So where the data science comes in is we're trying to make recommendations about what product for what type of business in what world region is the most likely to bring back the most amount of revenue so that we can all have bigger bonuses. That's the goal.
Yeah, I like money too.
And
Um,
that's one. Do you want me to do the other one real quick? So
oh
demand
yeah,
acceleration is how to get more money for Dell. We use data science, and the other one is cost of dissatisfaction. That's if you return or exchange something that you buy at Dell, that costs our company money. So we're trying to figure out, look at all the $1 billion that gets returned and look for patterns. And there was one recently where there was a camera issue where people meant to order something with a webcam, but it didn't come with it. It got dropped somehow, or there was mislabeled on the website, and so they were returning it for that reason. So we could proactively go fix that, and then less returns would happen, and so that saves Dell money too.
Oh, cool. Yeah, so I was gonna ask about the other projects where you're talking about, what was it again? Profits coming in.
Yeah, demand acceleration, trying
Demand
to make more
acceleration.
money.
Right, right,
Mm-hmm.
with the trials. So are you trying to look at all the trial information? You know, this particular product is working in this particular area, so that you can increase, you know, marketing and advertising in those areas?
Not necessarily. We would instead, so these are all sales people are offering this trial to a company or a big school district or something. And so it would be to let the salesperson know, hey, if you offer them a trial unit, a free trial, you'd be more likely to make the sale in these cases. And so
Oh,
it's
okay.
giving the information to sales, not necessarily to marketing or whatever, for when they should offer it. And then there's also, once we send out the trial, we have to make sure we get it back on time. And so I manage a few bots that send email reminders to the salespeople about when contracts are almost up. Like, those things don't just happen automatically.
Mhm.
When you get an email reminder about some subscription that you have, or anything for a video game, someone is in charge of making sure that bot sends you an email and that it doesn't crash and that the uptime is
Yeah.
a certain amount. Things I didn't think about before I worked in this space.
Yeah, right. So then what kind of programming languages are those bots written in?
There's a lot of Python, R. I would say those are the main ones for the bots, and SQL's used very frequently for gathering data from them. So.
How much data do you have in each of those projects? How many data points?
I mean, so it all exists in a data lake out in the cloud. I mean, petabytes. A huge amount of data. Yeah.
So it must take a while to process all of it for any given
It can. You
analysis
have
that
to
you're doing.
know what you're looking for, and you do a data pull of of specific subsets of data. And we have a lot of Power BI reports that help us visualize the data straight from the cube where the data is. So Power BI, do you guys use that? It's Microsoft's visualization tool. It makes graphs from your data that's live. There's other products that do it, like Tableau, Spotfire. They're all kind of equivalent products out there, if you've heard of any of those.
I think I've heard of Tableau, but I haven't really messed around with it.
Okay, yeah, similar thing. It helps you visualize your data. It makes graphs from very large data sets, because you're never going to comb through all that.
Right.
And so what our team does, is we kind of sit in between the business, which is the demand acceleration team or the cost of satisfaction team, that have a bunch of people with MBAs that work there, and then PAG, the performance analytics group, that really deals with the data engines. And we are the in-between that explain, we know from the business what the important things are. Like, we want to know what what world region it is, what product it is. Out of the billion data points, these are the types of things we'd be interested in. And then we translate that and we talk to PAG and we say, well, that would be a column that has this type of header and we need it in this data format, in a date. We need, we translate between English and technical or business speak, a lot of buzzwords into actual technical requirements. And that's a pretty cool space to be in.
Yeah, and that's all about, like you said earlier, tailoring your communication to your audience, right? The business world, when you're selling something, that's got to be different. When you're teaching people like you do in volunteering sometimes, and then the technical requirements and stuff, that's all totally different audiences that require totally different styles of communication and different rules. So that sounds hard.
It is, but it's fun. It's definitely the right place for me. Those are my strengths, and I think you'll find that for the students with a solid background in something like engineering or computer science, you can go anywhere, and it applies to literally everything these days. Mm-hmm. So you never know where you're going to end up. It's going to be extremely varied. You saw my path, and I'm not even so far into my career, and yours will also be varied that way. And I'm always interested in how just a little tiny bit of programming can help anyone. For example, my sister is an English teacher in high school, and my best friend growing up, and we're still close, she's a dance teacher. And they asked me for computer science type things. For example, my sister that teaches English, she wants me to flag for her any students that did well on both quizzes, but then failed the test because it was like the same material, and she would be able to reach out to them because there's just so many, or just any anomalies in that data she would want to know about, and it just made it easier to have a report rolled up. So I made her something in just Google Sheets, and she ended up sharing it with her other teachers. And then my friend that's a dance teacher, you've got one kid that's in tap and ballet, and another kid that's in ballet and hip hop, and you need to make a recital where no person who is in two different classes is in two numbers in the recital back to back, and they won't have time to change their costume. So that's a computer science question. Here's the variables, here's the requirements that I have. Make me a show order that allows everyone time to change their costume. So no matter what your hobby is, you can apply this stuff to it.
Those are great examples. Because totally, you can visualize any space, any field whatsoever that could, not that computer science is absolutely required in every single profession,
it just helps
but it enhances it. Yeah.
It can enhance literally anything you're doing. So this computer science background, by taking this class, will be so useful no matter what your major is, even if it's not computer science. Knowing those basics matters, and it'll help your dance teacher friend.
Or any friend, lots of friends.
Yeah.
Well, going back to the semiconductor space, it seems like the barriers to correct me if I'm wrong, but it seems like the barriers to entry into the fabrication room, the clean rooms, and all that is a little bit higher than at Dell. It seems like a lot of people can get these technical skills pretty easily on the internet for Dell. Data science, there's a lot of courses out there online, and then with programming and those kinds of things, hardware, I can learn a lot of that on my own. But over here at Los Alamos or Samsung, I don't know where I would learn that stuff if that's what I'm interested in. Is that kind of the thing? Like, I would really need to go to college, maybe grad school after that, and know what I want to do in order to get into here?
No. So there's all types of engineers work at Samsung. And so what they needed to know was problem solving, and they needed to know some basic like fluids, mechanics, some core engineering classes to be an engineer there. And I wouldn't say grad school is required. Also at the factory, there are a ton of jobs called technicians. You've got technicians and engineers, and those are the ones that keep the factory running. The technicians do the hands-on things. They're sitting in the factory for shifts during the day, getting things done. And the engineers make the plan. The technicians often have either military experience or maybe a community college degree. And sometimes they just are pretty mechanical. They like working on their car, and they still ended up at Intel or Samsung. And those are really good jobs that are well paying and very secure, and they don't require a 4-year degree.
That's awesome.
So I don't know the paths of the students on this call, but that is something that's definitely out there.
Yeah, I think a lot of Westwood kids are college bound. There's a culture in Westwood to go to a 4-year big school. But I am trying to collect a bunch of alternative paths that, like you said, still have that job security and satisfaction. It's worth it. Good enough pay. And so I'm looking at things like welding. Those are fantastic careers to get into. You get to travel the whole country or even the world if you wanted to. And yeah, it's always going to be there. So that's really cool. Technicians. Would that be like a manufacturing? I could go to a trade school and study manufacturing, or what is it called? Computer integrated manufacturing?
Yep, you could do manufacturing, anything like industrial engineering or industrial science, something with industry in the word, or anything with mechanical in the word, in the title. There's several paths. Really, they need people who can read a graph and understand it, and it's really more about the technical mindset, and that could be true of any of the jobs. The capacity to learn technical things. That's it.
Capacity to learn technical things. Would you say that's true for the data scientists and data engineers too?
Yeah, I would agree.
So it's really about what you're interested in, and then are you going to get the underlying soft skills? That's what you should be focusing on if you're a freshman, sophomore in high school, you think?
Yep. How to approach a problem, how to think through a problem. And that's what you get by just going through your classes. But that's what you really take. You know how I think I kind of felt this way in high school. When am I ever going to need this one chapter of math or this one specific chapter? And the truth is, you probably won't need that one specific thing, but you do need to know how to solve similar problems and how to think through problems. And that's more what you're learning in these classes, because there's no way one college or one high school can prepare any human for the hundreds of millions of tech jobs that are out there. So that also should make you feel better if you feel stressed about a certain class or a certain test that it's not clicking with you. That's okay.
Don't worry about it.
Everyone so I have a PhD. I work with all engineers all day, and a lot of them do too. All of us had a class that we sucked at. So just because you're not good at one thing, that doesn't mean that major isn't for you at all. And really, really remember that, because when you're in it, it feels like, oh, I'm not going to be good at this. I don't understand. And then I got to the real world, and I was like, oh, no one else gets this either. This is fine. We're all in the same place. And I didn't think that when I was in high school or when I was in college. I really didn't.
It was a push to get a 99, 100, and how much of your career, how much of your job is 99% successful.
Right. Well, I still have that perfectionist drive. That's a problem. And you know what else I was kind of disappointed to learn when I got to college is I worked so hard in high school to have the best grades and high placement and good test scores. And I was like, if I need to do this so that I can have a good job one day. And it turns out after that first job, none of that matters anymore. And you have to start over and you have to work hard again and you have to be like the best at that thing. So I thought that these things were so important because they're what gets me the good life in the end. But it was really it just taught me how to have perseverance, how to keep working even when you have setbacks. And that's the part that actually helped me in life. The straight A's whatever semester, that unfortunately that didn't matter at all later.
Well, it's really great to hear because I think my students now, that's what they can see, so the 97 that hurts and the 99, 100 that feels good. So it's really hard to distance yourself from that life and to think ahead into, wow, this won't matter a year from now, 2 years from now.
Yeah, I couldn't do that either when I was in high school. But I wish that I did.
Yeah, same. I got this advice repeatedly throughout high school as well. And it is hard. It's hard to look forward because you think that you're standing at this crossroads and every point you miss on this test closes some of these doors, and you want all the doors to be open to you. But I don't think that's how it goes.
You're right.
Yeah, it's not about every little tiny thing. It's about the big picture. So that's what I think we should be working hard at as teachers and students, is to how can we think more about the big picture instead of these little tiny events that won't matter a little bit after today. Well, students, do you guys have any more questions for Dr. Freeman? Thank you guys for coming and asking the questions that you did ask.
Yeah, I enjoyed getting to talk to you all. It's been a while since I've been able to do a classroom visit, so even virtually, this was nice.
Cool. Jasmine said thank you. Yeah, Dr. Freeman, thank you very much for coming. Like I said, each of those pieces of your career, I would love to talk with you more about those.
Yeah, we can do a session on one of them instead of the gamut where I just like spew them all at you and then ask if there's any questions.
No, it was great. It was great. I think I teach engineers too who are seniors, and so they might be more interested in the engineering part. But also, Dell has that too. So there's just been a huge variety of experiences that I think my students could really benefit from hearing about. So it's unfortunate that we only have a short amount of time today, but yeah, thank you so much for being here and for talking to us about all of those experiences and all of the advice that you've given. It's been super helpful, I think.
Okay, great. Oh, it says there's one more question. I don't know how much time we have. I don't know what time this is.
Yeah, no, it's fine. Yeah.
Okay, all right. It's the last one. You want to just come off mute and ask?
Yes. What motivated you to get back up when you had a setback?
That's a good question because there's been many. I think one setback that I had was during grad school, my project had lost all of its funding, and I was still super determined to get my PhD. And I had to find a different professor and change my topic slightly. And that was a huge, huge ordeal, but it was just really caring about the end goal. You know, I wasn't going to let this be what stopped me from getting a PhD. I pulled up this slide so I can just think about different jobs. There's been some setbacks in specific projects, especially within the data science world. You can't get what you need. But I think it's just really keeping a clear picture in mind of the end result that you're looking for was what helped me.
That's a great question, Ayush. Thanks for asking that. You seemed very positive when you were talking about these projects that taught us that something doesn't work. So I like that. I think some of my engineers kind of experienced that this year with their projects. Some of them.
It's the most common thing. It's not even like half the stuff you try works. That's not how it goes.
That's good. That's good to hear.
Yeah.
I have one question. In the Netherlands, are there really that many tulips? Do the tulips look that great?
There are, except they're in the spring, and I was there in the summer.
No.
but there are. It does. They're everywhere in every gift shop and everything.
That's awesome.
A random fun fact about the Netherlands is so all the people are very tall. And you can't tell from video, but I'm small. I'm 5 feet tall. And the apartment in the student housing where I was, like the bathroom mirror started at 5 feet. So like I was completely below it. Wow. And there was a lot of things in the lab that I just couldn't reach. That's things you don't think about when you go work in a different country.
Interesting. Yeah, students, I hope you guys get to go to other countries in your undergrad or wherever. Whenever you get a chance to, definitely jump on it. Even if it costs too much money, you think, it doesn't matter. Find a way to get the money and go on it. Because the study abroad experiences that I had are just irreplaceable in my life. Transformative.
I agree. And because these were all centered around research, they were all paid for by the college. I actually earned money by going. I was paid for the research that I did. And you can find that's pretty common within science and engineering and computer science. There's funding for that.
Yeah.
There's the comment, I was rejected from a NASA internship. You know what? I was rejected from a lot of other internships too. This is what I did do. And your story is going to be the same. Everyone has how they ended up, and don't think that they got 100% of what they tried to get either. Same for projects working out. It's just not how it really works in the real world.
That's great to hear. You've got a lot of really awesome looking logos, the NASA, the Los Alamos, those are huge names. But yeah, if I were to put a slide of my rejected applications, it would be 1 billion.
Yeah, so and that's maybe something we should all talk about more, because that's true for even the most successful person you can name.
Mm-hmm. That's awesome. Thanks for sharing that, being vulnerable with that.
If there's anything that high schoolers need to know, it's that.
Yeah, for sure.
Can people apply for internships when they are in high school? Yes, you can. It's more rare. It's because you have to be 18 years old to sign an NDA, a non-disclosure agreement, to work at a company. And so that's usually the factor, because I've worked on trying to set up some internship programs where I've been. So once you turn 18, it becomes a lot easier. Otherwise, job shadows are a really good way to get to know what different industries can be like. And that's another thing why you're so fortunate to be at Westwood, because they do things like that.
You'll have opportunities like that at Dell?
We have interns that start at 18, yes.
Sorry, 18. Cool.
Yeah, so there are some high school seniors, but and there's something that's integrated in a school. I think it's even here in Austin for it's an underprivileged school where they have a tech support on campus that students run the tech support, but they run the tech support for other students, but they get training and mentorship from Dell employees. So I don't think it's a paid internship, but they do kind of get experience being an IT person, so they could do that after they're done with high school if they want to.
Well, we could set that up here.
Yeah. There's a different person that runs that, but I can reach out to her if that's something you're interested in.
Yeah, I think somebody would be at the school. A few
Yeah.
students. Yeah. All right. Well, it's been about an hour, so I think that's good. That's a long amount of time. I think the last interview that I had like this, we kind of quit talking after 30, 40 minutes, and so you have a very full resume here that, like I said, we could talk for a long time about. And the students that we had today were awesome with their questions. So thanks everyone for coming. If you don't mind, for the last one that I did, I put it on YouTube so even more people could see it. That's okay?
Okay, sure.
Okay, awesome. Yeah, so I'll do that. I think I need to go. My wife is at home with the kid, and I'm getting super hungry.
Yeah, I think mine are probably hungry too. So.
Perfect. Well, thanks again. I'll see you at the next advisory meeting, the board meeting.
Yes, it was really nice chatting.
Yeah, thanks a whole lot. Thanks for being here, and thanks for prepping what you prepped and answering all our questions and giving us all this good advice. Appreciate it a whole lot.
Bye.